Hello viewers, in today's class we are going to solve some problems related to partial fractions, and here I am taking this problem, and this problem contains in the denominator we have a linear factor. This is a linear factor and this is a quadratic factor which is not factorizable into linear factors, right? So here we cannot factorize x square plus 1 into real linear factors. So what we will do here, x square plus x plus 1 divided by x plus 2 x square plus 1 can now be written as a sum of two fractions. The first one is a divided by x plus 2, so here we have the linear factor, and then we have bx plus c, and this is bx plus c divided by x square plus 1, right? Because whenever we have a quadratic function in the denominator, then we have the numerator in the form of bx plus c, right? Okay, now this can be written as a times x square plus 1, then we have bx plus c times x plus 2, and in the denominator we have x plus 2 x square plus 1, right? So now this expression can be written as x square plus x plus 1 is equal to a times x square plus 1 plus bx plus c times x plus 2, right? So we have decomposed this rational function into two partial fractions, and the first one is a divided by x plus 2, and other is bx plus c over x square plus 1. Taking the LCM, we got this expression, and then you can say cancelling out this term and this term, x square plus x plus 1 is equal to this expression. Now it can be written as x square plus x plus 1. Here we can write a times x square plus 1. This can be written as bx square plus 2bx, then we have cx and 2c, right? So this can be written as collecting the coefficients of x square, we have a plus b times x square, then we have 2b plus c times x, and the constant term is a plus 2c, right? Now we can equate the coefficients of both the sides. Here we have 1, here also we have 1, so the coefficient of x square here it is a plus b, and this a plus b is equal to 1, and 2b plus c is again equal to 1, and this is a constant term, so we have a plus 2c is equal to 1, right? Okay, now here we have three variables a, b and c, and we have to find the values of a, b, c, which we can do by solving these three equations, right? So if I subtract this equation and this equation, then a plus b is equal to 1 and a plus 2c is equal to 1, and if we subtract these two equations, a get cancelled, we have b minus 2c is equal to 0, and b is equal to 2c, and if we substitute this value in this equation, then we have 2 times of 2c plus c is equal to 1, so this is 4c plus c equal to 1, 5c equal to 1, c is equal to 1 over 5, right? Now substituting this value here, the value of b becomes 2 by 5, and if we substitute this value of b here, we get a plus 2 by 5 is equal to 1, and a is equal to 1 minus 2 by 5, that is 5 ones are 5 minus 2, that is 3 by 5, right? So we have obtained the values of a, b and c, and let us substitute these values in this expression. So I becomes integral, we have for this we have a divided by x plus 2 plus bx plus c divided by x square plus 1, and here we have dx, right? Okay, now if we substitute the values, the value of a is 3 by 5 here, and this is x plus 2, then we have the value of b as 2 by 5 x plus the value of c is 1 over 5, right, divided by x square plus 1, and here we have dx, right? Okay, now if we write this expression as 3 by 5, and here we have integral dx over x plus 2 plus here if we take 1 by 5 common, then we have integral 2x plus 1 divided by x square plus 1 dx, right? Now this can be written as 3 by 5, this is log of x plus 2, and because the integral of 1 over x plus 2 is log of x plus 2, then we have 1 over 5. Again split this integral into two integrals, so we have 1 over 5 2x over x square plus 1 dx plus 1 over 5 integral of dx over x square plus 1, right? Okay, now this expression can be written as this is 3 by 5 log x plus 2, and then we have 1 over 5, and see the derivative of x square plus 1 is 2x, so this is simply log of x square plus 1, and then we have 1 over 5, and this is log of this is 1 over 5 tan inverse of x, right, and plus c. So this is the final integral of this function. Now viewers, let us take another problem. Now here this problem is slightly different from the problem which we have just solved, and here we see that in the numerator we have 1, and in the denominator we have two quadratic functions. This is also a quadratic function, this is also a quadratic function, and both these quadratic functions are not factorizable into real linear factors. So what we will do, we will have the partial fractions of this type. So here we have ax plus b divided by x square plus 1, right, and then we have cx plus d divided by x square plus 2, right. So this is a quadratic function, so the numerator must be of the form ax plus b. Here also this quadratic function is not factorizable into real linear factors, so we have cx plus d in the numerator, right? Okay, so now what we will do, we will take the LCM. So we have ax plus b times x square plus 2, then we have x square plus 1 times cx plus d, and divided by x square plus 1 times x square plus 2. Now cancelling out these two terms, we can say that 1 is equal to ax plus b, and here we have x square plus 2, then we have x square plus 1, and we have cx plus d, right? Now let us multiply and rearrange the terms. So we have ax cube, then we have 2ax and bx square plus 2b. Here we have cx cube, this is cx cube plus dx square plus cx and plus d, right? Now if we collect the like terms, then we have a plus c x cube, then we have b and d. Here we have b plus d x square plus, then we have this term 2ax and cx, this is 2a plus c, and here we have x, and then we have 2b plus d, right? Okay, now we will compare the coefficients of both the sides. So here we have only 1, and there is 0 is the coefficient of x cube here, so a plus c is 0, then b plus d is also 0, because here we do not have any term containing x square, and 2a plus c is again equal to 0, and this is the constant term, so 2b equal to 1, right? So 2b plus d is equal to 1. Now here we have 4 equations, and we have 4 variables to calculate. So what we will do, we'll solve first these two equations, that is a plus c is 0 and 2a plus c is equal to 0. If we subtract these two equations, then c cancel, and we have minus a is equal to 0 and a is 0, and if we substitute a equal to 0 here, then c becomes 0, right? Okay, now similarly if we solve these two equations, that is b plus d is equal to 0 and 2b plus d is equal to 1, and if we subtract these two equations, then dd get cancelled. Here we have negative sign, b minus 2b is minus b, 0 minus 1 is minus 1, so b is 1, right? And if we substitute b here, then 1 plus d is 0, so d is equal to minus 1, right? Okay, now we substitute these values a, b, c, d in this expression, so our integral I becomes ax plus b divided by x square plus 1, then we have cx plus d divided by x square plus 2, and here we have dx, right? Okay, now if if we substitute the values, so a is 0 here, so and b is 1, so this expression becomes 1 over x square plus 1, and c is again 0, and for d we have minus 1, so we have minus 1 over x square plus 2 dx, right? Now if we separate these two integrals, so we have 1 over x square plus 1 dx, and then we have 1 over x square plus this 2 can be written as the square of square root of 2, right? Now here we will make use of the formula, that is if we have x square plus a square, then the integral of 1 over x square plus a square is 1 over a, and then we have tan inverse x over a. Now applying this rule to these two integrals, so we have this integral is tan inverse of x, then we have here we have 1 over root 2 and tan inverse of x over root 2, and then we have the constant of integration as c, right? So this is our integral of this function, that is 1 over x square plus 1 times x square plus 2. Let us take this problem. So here we have to integrate the function 8 divided by x plus 2 times x square plus 4. Now viewers, here see, this is a linear factor and this is a quadratic factor which cannot be further factorized into linear factors. So here we have decomposed this rational function into two fractions. For this linear factor we have a over x plus 2, and for this quadratic function we have bx plus c divided by x square plus 4. Now taking the LCM, we have a times x square plus 4, then we have x plus 2 times bx plus c divided by x plus 2 x square plus 4, right? Now see this denominator and this denominator, these two factors get cancelled, and we are left with 8 equal to a times x square plus 4, then we have x plus 2, and this is bx plus c, right? Now multiplying these two factors and these two factors, we have ax square plus 4a, and then we have bx square plus cx plus 2bx plus 2c, right? Now we can rearrange these terms, so we have a plus b times x square plus we have c plus 2b, collecting these two terms, c plus 2b x plus then we have 4a plus 2c, right? Okay, now we will compare the coefficients of x square x and the constant term in both sides. So here we do not have any term on containing x square, so we have a plus b equal to 0, and similarly we have c plus 2b is equal to 0, and for 4a plus 2c this is equal to 8, right? Because this constant term is equal to 8, and here we do not have the coefficient of that is the term containing x square, right? And similarly there is no term containing c plus 2b. Okay, now if we here we have 3 variables and 3 equations to solve. So what we will do, we will first of all we can solve these two equations, right? So from this equation we have c is equal to minus 2b, or we can say b is equal to minus c by 2, and substituting this value in this equation, we have a minus c by 2 is equal to 0. So a is equal to c by 2, right? Now substituting a is equal to c by 2 here, we have 4 times of c by 2 plus 2c is equal to 8, and this is 2 2s are 4, so we have 2c plus 2c. 2c plus 2c is equal to 8, so we have 4c equal to 8, so c is equal to 2, right? Now substituting c equal to 2 here, we get a is equal to 1, and c is equal to 2. Here if we substitute, then b becomes minus 1, right? Now once we have obtained the values of a, b and c, this integral can be easily evaluated. For this we can write a over x plus 2 plus bx plus c divided by x square plus 4, and here we have dx. Now substituting the values, a is 1, so we have 1 over x plus 2. Then we have for b we have minus x, and for c we have 2, and this is x square plus 4 dx, right? Now separating the terms, we have 1 over integral of 1 over x plus 2 dx, then we have x over x square plus 4 dx, and then we have 2 times dx over x square plus 4, right? Here we can multiply the numerator by 2 and multiply the denominator by 2, or in other words we can say that if we place 2 in the numerator and 2 in the denominator, then the derivative of x square plus 4 becomes 2x. So now the integral of 1 over x plus 2 is log of x plus 2, then we have minus half, and the integral of 2x over x square plus 4 is log of x square plus 4, and then for this we have 2 times actually this integral becomes, now this integral can be calculated by the formula, that is dx over x square plus 2 square is can be written as, or in general we can write x square plus a square is 1 over a tan inverse x over a. So here we have for 4 we have 2 square, so this is x square plus 2 square, so we can we can apply this formula, so we have 1 over 2 tan inverse x over 2 plus c. This 2 and this 2 get cancelled, so our final solution is log x plus 2 minus half log of x square plus 4, then we have plus tan inverse x over 2 plus c. C is the constant of integration.